without spawning. The calcium carbonate foundation secreted by hard corals can be 1 kilometre thick in places and hundreds of thousands of years old. The living reef we see today is just a thin veneer on top, made up of many different species, including soft corals, fan corals, and sponges, gorgonians and crinoids. All told, coral has evolved into more than 1,000 hard coral species and over 700 soft corals, each perfectly specialised to fill its own niche. Understanding how corals build reefs highlights the seriousness of climate change and how it threatens this complex ecosystem. Our oceans have always absorbed atmospheric CO2 like a giant sponge, but now those levels are so high that the water chemistry is changing, a process referred to as ocean acidification. Alkalinity is falling, and naturally occurring carbonate ions are being affected. Many marine creatures need these ions to produce calcium carbonate for their shells and skeletons. Hard corals need them to build reefs. Ocean acidification seriously threatens all these processes. But in every natural catastrophe, there are winners and losers. Jellyfish are distant relatives of coral, but unlike coral, they are more adaptable to changes in water temperature and chemistry. Their numbers are already on the rise, and they are making our seas sting. Coral's other ancient cousin is the sea anemone. Like coral, the anemone is a simple being that has been highly successful. In fact, the anemone is like a huge coral polyp. At its centre is a mouth surrounded by a vast mantle of stinging tentacles. Within the mouth is a big stomach filled with acidic enzymes. Because the anemone does not have a solid physical structure or skeleton, it does not rely on calcium carbonate, so it's not as vulnerable as coral to ocean acidification. But like coral, some species possess zooxanthellae algae, and warming seas will also cause them to bleach. There are over 800 species of sea anemone. 10 are suitable homes for anemone fish, and this is one of the reef's most marvellous partnerships. The anemone's tentacles normally sting invaders, but these fish are coated with a protective mucus and can dance in and out unharmed. The fish rarely wander more than a metre away. Everything they need is right here: scraps of food, protection, and community. Not surprisingly, the fish lay their eggs near the protective folds of the anemone, aerating and defending them until they hatch. And being stuck in one place hasn't harmed their sex life. In fact, it's enhanced it. To keep everyone satisfied, they've mastered sex change. If a dominant female is required, a male can change sex. If a dominant male is needed, a subordinate male accelerates into sexual maturity. As ocean conditions change, anemone fish seem more protected than most, safe within those stinging arms. But even they are not immune from danger. All fish have internal structures and organs which may be weakened by ocean acidification. Even now, scientists are finding that the ear bones of fish are being affected, which is impacting the way they communicate. If ocean acidification goes unchecked, it may affect key metabolic processes for all marine animals. Whenever conditions get more challenging, the natural process of selection just gets more ruthless. Those that cannot cope will be quickly cast aside. Every citizen must earn its keep. These shrimp gather in locations referred to as cleaning stations. This particular station also happens to be the home of a moray eel. But the shrimp aren't running away. If anything, they're competing to get closer. And although the eel finds the shrimp irritating, he just grins and bears it. The reason why these entirely different species tolerate one another is because they have an unspoken agreement. The shrimp has the important job of removing parasites, as well as dying or dead flesh. These can be fatal to the moray, but provide a delicious banquet for the shrimp. Animals are engaged in complex relationships right across the reef. Going solo is risky business, and if you're going to attempt it, you'd better be very clever. One clever survival tactic is camouflage. Decorator crabs attach tiny sponges, corals and anemones to their shells and look more like walking flower beds than animals. Others attempt to go incognito by placing toxic sponges on their heads, like these aptly named hat-carrying crabs. Sponges are living creatures, but the crab doesn't care, cutting the sponge up into whatever size fits. Other crabs collect forest leaves and use them for disguise and as hang gliders. Boxer crabs are always ready for a fight, with tiny poisonous anemones as boxing gloves. Hermit crabs reinforce their own body armour by wearing second-hand shells. Bigger shells must be found as the crab grows, and this gives the crab lots of time to develop its own unique look. More sophisticated hermit crabs collect stinging anemones and will remove these anemones and reattach them whenever they change shells. Crabs date back to Jurassic times, 200 million years ago, and over 10,000 species exist. Their hardy souls, even missing half their legs, won't slow them down. And they're great opportunists, some feasting inside a sea cucumber's mouth. Sea cucumbers have some remarkable physical adaptations themselves. They breathe through their rear end, move on hydraulically powered tube feet, and have a special collagen in their body wall that enables them to radically change shape. They also spawn from their forehead. Sea cucumbers have few natural predators, so it's no wonder they're a popular taxi ride for crabs and shrimp. Because the sea cucumber stirs up food with its front end, there's even a free meal as part of the ticket. Nudibranchs are also great to hitchhike. These highly poisonous sea slugs offer guaranteed safe passage through dangerous open territory, with the shrimp scavenging on the run. But for first-class travel, nothing compares to a jet-propelled jellyfish. Magic carpets also glide above the reef in the form of flatworms. Flatworms and nudibranchs don't have shells, so draw on chemical warfare as defence. Some eat toxic hydroids and anemones and sequester poison in their skin, which in turn makes them poisonous to any potential predator. They advertise their toxicity with bright, bold colours and patterns, which have conspired to make them incredibly beautiful. They are as wild in character as they are in appearance. They have gills on their backs, sex organs on their sides, and all of them are hermaphrodites. And some are fierce cannibals. Trying to eat your lover during sex is not quite acceptable, but snacking on a cousin is fine. Joining the sea slugs on the ocean's floor are the sea stars. Sea stars are often referred to as starfish, but they're not fish at all. They're echinoderms. Echinoderms date back over 500 million years, so predate the evolution of coral. They have evolved into a wide range of life forms, and what many have in common is the spine. Urchins are some of the most heavily spined of all, but for some colour-coordinated crabs and shrimp, this isn't a deterrent. They've adapted to live amongst the spines and remain there all their lives. It's a classic case of symbiosis on a reef and worlds within worlds. Tropical oceans are like vast blue deserts and largely nutrient poor. On coral reefs, nothing goes to waste. Various specialist filter feeders have evolved to sift the passing currents, capturing, digesting, and recycling every available bit of food. Worms are among the most numerous and diverse of all filter feeders. 20,000 marine species exist, and unlike the earthworms, they're an exotic bunch. Befitting their name, Christmas tree worms unfurl festive, feathery mouthparts, which they use like tiny nets. Their bodies, meanwhile, are buried in the coral and rarely seen.